So here we have our quadratic equation. Y is equal to 6x squared minus 7x minus 20. And some of the things that we know are that our x squared value is going to wind up in our top left corner when we do our table method. And I have duplicated the table twice just so that we can play around with some of the features. We also know that our constant value, negative 20, is going to go in the bottom right corner. So first, let's go ahead and focus on this 6x squared. So we know that we're going to have one x and one coefficient in front. So there are multiple different values that we could have in order to get 6x squared. They already played around with a lot of the features, so we know we're not going to use 1 and 6 as the factors. We're going to use 2 and 3 as the factors. Okay, so all I did was go ahead and bring up the 3x and the 2x, which are going to multiply to give us 6x squared. Now, given that, we wanted to know some factors that would get us to this negative 20 bit, because whatever we have here multiplied by what we have here is going to give us the negative 20. Keep in mind, these two values are going to have to add up in order to equal my middle value, the negative 7x. So again, I have my squared value, my constant value, and then my x values that will come out. And that's because I'll have 3x times a constant over here, and I'll have 2x times a constant up here. So that's why both of these will give me my single x values. Here, I would just have my two constants multiplied by each other. And in this box, I have my two x's multiplied by each other. So again, we have our x squared term, our x terms that we'll have to add together in order to give us what our final x term is here, and then our constant value down here. So they already, again, went ahead and configured, and it's basically just a lot of guess and check and trying to figure out how the different variables will play together, but they've already told us that it was negative 5 and 4. So if we go ahead and we put the negative 5 and we put the 4 here, and then we go ahead and we do the mathematics behind it. So in our first method, we have 3 times negative 5, which gives us negative 15. And then we have our x that comes down as well. In my second box, I have the 2 times the 4, which gives us the 8. And then I just have the x as well. And there's nothing to multiply as far as variable goes up here. So it's just 8x and negative 15x. So if I switch the placement of my variables, if I put the 4 down on the left and the negative 5 up on the right, I would get 3 times 4, which is equal to 12x. And I'd get negative 5 times 2x, which is equal to negative 10x. So now if I go ahead and I try to figure out how this is going to come out, again, we know that both of them are going to have the 6x squared, and we know that also both of them are going to have the negative 20. The thing that we are trying to figure out is what is the sum of each one of these and how is that different? So over here, if I do negative 15 plus 8, I get my negative 7x. On my right-hand side, if I do 12 minus 10, I get 2x. But because we wanted the negative 7x, we know that we want this one over here. So this is going to be the way that we would group our different pieces. So in the end, I would have my one set of factors, which is 3x plus 4. And I'd have that multiplied by my second set of factors, which is 2x minus 5. And this would be my final factored problem for 6x squared minus 7x minus 20. So it's not that they knew right off the bat to put the negative 15x in the bottom left and the 8x in the top right. But when you set up the factors the way that you need them, that's how it comes out with when you multiply them through.